All right, let's do section 9.2, page 454, number 3, which says, estimate the limit graphically and then use L'Hopital's rule to find the limit. So for number 3, we have the limit as x goes to 2 of the square root of 2 plus x minus 2 all over x minus 2. So when I draw this using my calculator, and I just use the standard ways that we graph functions, so I've got x and y, and I let my x-axis go up to about 1, and I got something that looked like that. So it certainly seems like my function is going to approach a limit as x gets very large. So that gives me hope that there's going to be a limit. And we have a bunch of methods that we use to evaluate limits. So the first thing to do is to graph, which is indicating that there probably is a limit. The second thing to do is to substitute in. So let's do that. Substituting in means every time that I see an x, I put a 2 in. So this is going to give me the square root of 2 plus 2 minus 2 all over 2 minus 2. Well, I'm definitely going to get a 0 in the denominator. And this is going to be the square root of 4, which is 2. So I have 2 minus 2, and I'm going to get 0 over 0. Now, before we jump to L'Hopital's rule, even though the instructions say to use it, let's think about our other methods for evaluating limits. Is there any algebra that we can do? Not really. Can we use end behavior modeling? Not very easily, because we don't really have a polynomial in the numerator. So we're going to have to use L'Hopital's rule. And let's remind ourselves what L'Hopital's rule says. So we're going to have the limit as x goes to a of f of x over g of x. And if that is equal to an indeterminate form, 0 over 0, infinity over infinity, then it's going to be equal to the limit, again, as x goes to a of f prime of x over g prime of x. Now, I know that problem number 3 comes right after theorem 4, which is the first form of L'Hopital's rule, but I'd like you to get used to looking at the stronger form, because the book, a quiz, a test, the AP exam isn't going to tell you whether to use the first form or the stronger form. And as we talked about when I introduced L'Hopital's rule, the first form really comes right out of the stronger form. So let's identify f of x as the numerator here. So that's going to be the square root of 2 plus x minus 2. And I'm going to have to take the derivative. And remember, I take the derivative of the numerator separately from the derivative of the denominator. So just to make my derivative taking a little easier, I'm going to remember that the square root of 2 plus x is 2 plus x all raised to the 1/2 minus 2. And then let's take f prime of x. So I'm going to bring that 1/2 down. I'm going to have 2x plus 1. I have to decrease the numerator by 1, so I get negative 1/2. And then this negative 2 over here, when I take its derivative, I just get 0. All right. Well, g of x is going to be what's in the denominator. So that's going to be x minus 2. And g prime of x is going to be what? It's just going to be 1, because it's just going to be the derivative of x, and the derivative of that negative 2 is going to be 0. So I'm going to have the limit as x goes to a of f prime of x over g prime of x. And for our particular problem, I'm actually going to take the limit as x goes to 2. And I'm going to substitute in for f prime of x, so I'm going to get 1 over 2 times 2 plus x to the 1/2 divided by 1, because that's what my g prime of x is. And now I want to try substituting in. So I'm going to have 1 over 2 times 2 plus 2 to the 1/2. all over 1, although I'm not going to write that anymore. And that's going to give me 1 over 2 times the square root of 4, because 2 plus 2 is 4. That 1/2 exponent tells me I'm taking the square root, and that's going to leave me with 1 over 2 times 2, or 1/4. And if you look a little more closely at your graph, you'll see that this flat part up here is really about 1/4 of the way up from where y is equal to 0.